All right, this question here, let's grab the highlighter. It says, for this reaction, here's my reaction. The Kc is given 0.5. That definitely tells me some information, but we won't review that part yet because we've been reviewing. It says, decide if each of the following situations concerning concentrations give equilibrium or not. Now, when you see that verbiage, decide if, equilibrium or not, you need to tell yourself Q. This is a Q problem. And Q just means same expression as Kc, but I don't know if it equals the Kc value, the numbers I have been given. Might, but might not. You have a third of a chance of it being yes, a third of a chance, 2/3 of a chance of it being no, and then you have to decide which way does it shift. So let's write down, let's grab the pen and say Kc expression for this equation is NO squared times O2 to the first divided by NO2 squared. But when I have numbers and I don't know their equilibrium, I'm not going to call it Kc anymore. I'm going to call it Q. And I'm going to compare Kc to Q at the end because I already have the Kc. The Kc was given right here to be 0.5. So let's take those numbers right here from letter A and let's put them in. If all of them are 0.1, 0.1 molar squared times 0.1 molar to the first divided by 0.1 molar squared. I don't need a calculator. Jordan doesn't need a calculator because 0.1 squared divided by 0.1 squared goes away. And so my Q, Skylar, is what? 0.1. All right, Kc is 0.5 and Q is 0.1. Now let me write it down for you the way Nimsy showed us to write it down for you guys. Kc is bigger than Q. Now, Hayden, what is any K values expression? Who over who? Products divided by reactants. So if I have a value that's not big enough, products divided by reactants, Matt, who do I not have enough of? I don't have enough products. And who do I have too much of, Janae? Reactants. So how in the world, Ira, do I get products to go up and reactants to go down? For this reaction, what does he have to do? For this reaction, what does he have to do if the products have to be bigger and the reactants have to be less? Kelsey, what does he have to do? The values have to go up on the product side and the values have to go down on the reactant side. So which way does the reaction have to, as it says, go? Right or left? That makes the reactants go up and the products go down. Then right. Good. Okay. Now, here's the way Nimsy says I can have you cheat. Which way is the arrow pointing? It's pointing towards the right. Yes, it's pointing towards the Q. But if you set it up alphabetically, where the K is on the left and the Q is on the right, then it tells you basically once you've done that which way it has to shift to establish equilibrium. Now, I don't care for that because that means you've memorized something you don't understand. I want you to understand that when Q is not as big as Kc, it hasn't reached equilibrium yet going from left to right, correct? Okay, so let's jump on. We're just going to skip this one because I know you can do the same thing and do another Q comparison, but I would like to move on to the next one. Make sure we cover some ice chart information. So everybody flip their paper over. We're now at question number 6 on the back, so change it from 5 to 6 on the back, please. I'm going to grab the highlighter, and it says to me this. 4 moles of H2 and 4 moles of I2 are placed in a 1-liter container at that temperature period. All right, I'm going to highlight the reaction. I'm not going to read any farther. 4 moles of hydrogen and 4 moles of iodine are placed in a 1-liter container at 520 degrees Celsius. Here's the equation. So I need everybody on your paper to do what I'm doing. I need you to write down that equation. Need some space with it. Hydrogen plus iodine yields an equilibrium. 2 moles of HI, they're all gases. Today I'm going to teach you how to solve all equilibrium mathematical questions that are beyond just plug and chug into the KC or KP. And it's called the ice chart or the rice chart. If you've done your reading, you've done your Nimsy note reading, you know what I'm talking about. Now, R stands for the reaction right here. I stands for the initial values. C stands for the change in those initial values. And E in my rice or ice chart stands for equilibrium has been reached. Now, you and I are going to do stoichiometry in our ice chart. And we're going to use the coefficients as usual, because when I say the word stoichiometry, you should think coefficients, coefficients, coefficients. Yes? Okay. Now, what do we start with? We start with 4 moles per liter. So I'm going to write that down as 4 moles of this and 4 moles of that, sitting in 1 liter. Did they mention anything about the HI at all, Stephanie? In that first sentence that I highlighted, did they mention anything about HI? No, they did not. So how much HI Hayden should I record that I have initially? How much? Nada, 0 moles, none. Why? Because they didn't give me a value for HI. Very important in the reading and the interpretation of that reading into your ice chart. All they said to you was hydrogen and iodine. Everybody else is 0. Otherwise, they would have mentioned it. They did not. Okay, if I have no product, what's the only logical thing, if this is 0, what's the only logical thing for this reaction to do in its change? Which direction is the only logical reasoning, Ashley, for this reaction to go towards? I have no product and I have reactants. So with this being 0, what's the only logical reasoning that my change is going to happen in what direction? Can 0 become anything less in chemistry? No. I have no products. It cannot go left. What's the only way it can go? Right. Did my arrow mess you up? Okay, sorry. Did not mean for that. I was just pointing to the 0 here. Sorry. So we'll just say, oops, oops, messed up students thinking. Okay. So the only logical way for this reaction to change is for it to go from left to right, correct? Okay. So we're going to record minus x, minus x. They have coefficients of 1s. That's why they're only minus x and minus x. But over on this product side, because I'm making product, it's going to be plus, and it's going to be plus how much x? Ah, there's the stoichiometry right there. Plus 2x. That is exactly because of its coefficient. The ice chart, Matt, is just stoichiometry, a little magnified. All right, so at equilibrium, what I have at equilibrium is 4 moles minus X, 4 moles minus X, 2X moles, product side. At equilibrium, those are my exact equilibrium values. Not yet. Not yet. Now I want you to notice something. Let me grab the highlighter again. I haven't taken you any farther than sentence number 1. All we've done is read sentence number 1, looked at the reaction right here, and then from there, we just did an ice chart. Here's my ice chart right here. Now let's read a little farther to help me figure out how to get a KC value, because ultimately that's what I'm going to do right here. The ultimate goal is find the KC value. So they've got to give me some info. They've got to give me somehow the ability to find X. So when we read a little further, it says the hydrogen and iodine react according to the following equation, and let's change our color a second. And if that many moles of H2 remains when equilibrium is reached, let's do our A, our B, and our C. I never promised it would be a rose garden and easy, did I? But the ice chart is our saving grace for the next 4 chapters, including this one. Okay? What did they give me? Moles of who? Oh, they said at equilibrium, the concentration of H2 is 0.063 moles per 1 liter. Because the volume hasn't changed. What have I said that hydrogen is at equilibrium? 4 minus X. So does that mean that 0.063 moles is equal to 4 minus X? Do I know X? I can find X. That is how this ice chart is working. The first sentence, I created an ice chart. I read on to discover the amount of H2 at equilibrium, which ultimately allowed me to find X. At equilibrium, it's my best attempt for a double arrow. Let's erase it real quick. Let's erase that. At equilibrium, there you go. Is that better? Okay, at equilibrium, the hydrogen value is told to us to be 0.063. I've already decided at equilibrium based on my ice chart that 4 minus X is my equilibrium value. Therefore, 0.063 is equal to 4 minus X. Agree with that statement? Okay? So, Janae, what is 4 minus 0.063? Because that gives me X. Now I have X. Now, if I have X, I have everybody at equilibrium. Agreed? And if I have everybody at equilibrium because I now know X, can I find KC?